Hey everyone, this is going to be the second GBM of the semester, and for this one I am going to introduce the ESP32 dev module. So, getting started, a little introduction to microcontrollers. So, a microcontroller is basically just a simple, very simple, like a computer that can complete a very basic program. Usually, they can only run one program at a time. They don't really have an operating system, more firmware. They contain a processor, it can have memory, both long-term and um, volatile. Provide a collection of a bunch of input-output pins, and generally used for small, like low power or low size places. Arduino is a very powerful line of, or very popular and powerful line of microcontrollers. They let you quickly test out circuits, let you upload your own program. It can be used for rapid prototyping, all through just a USB port. This part is the actual controller, and everything else is just uh, stuff to make accessing that a lot easier. This is one of the big things that microcontroller boards are so popular, is just because they abstract away all the little things you need to worry about when you're dealing with hardware like this. The software is also pretty amazing because it's written in a version of C++. It is C++ at the end of the day, but they add their own couple of their own functions and constants that make it easier to interact with the hardware itself. The Arduino IDE is probably the real secret sauce behind Arduino. It handles everything from compiling to uploading to any other libraries you want to import or anything else like special you want to do. This is what takes everything you have and just uploads it, programs to the board as it should be. You don't even have to worry about typing a command into a command line anywhere. It just does it for you. This is what it looks like. It's pretty simple. There is another way to program Arduinos. That's Platform IO. I may get into that for like a future TPM, but for starting out, this is all you need. It has this setup function right here. This is where it only runs once. So if you want to define anything that is again like set up for the program, like you want to start up the serial channel or the serial thing, or initiate a class or anything. This is where you would do that, and then the loop is what's gonna keep on running literally forever. That's what that is like the part of the program that's gonna continuously look for inputs, look for any changes that happen. All that is from there. So this runs, and as soon as that runs, this starts happening. So the ESP32. So ESP32, much like the Arduino, just copy and paste for everything I said with Arduino, is does everything Arduino does, but also includes built-in Wi-Fi and Bluetooth. On top of this, it does use the Arduino IDE, and it takes like memory and speed and increases that quite a bit. Uh, this here is a more in-depth uh, comparison of the two, where this is a little ESP32 is a little smaller. It's got a lot more I/O, more analog pins, and the little asterisk right there means that when you're using Wi-Fi, you can only access 8 of those pins. Has actual DAC pins, and the real cool part of it is the processor right here. The Arduino Uno has a at Mega 328P processor, which is only 8 bits and runs at 1600 megahertz, while the ESP32 has a 32-bit that runs at 2400 megahertz at the maximum, which is pretty crazy to think about in terms of this package and just how cheap it is. In terms of memory, the Arduino has the ESP32 has 4 megabytes versus 32 kilobytes of memory and for flash, and 320 kilobytes of memory for SRAM. What it does not have is EEPROM. EEPROM memory is memory that lets you that sticks between reboots. So if you want to save something to EEPROM, like a variable or something, that variable will be saved, and next time you reboot the whole microcontroller, you'll be able to still access that variable and the data will be saved. It doesn't have this, but I've never been in a situation where I've needed to use EEPROM memory, so I don't think it's too much of a uh, con. Um, Voltage level. One of the big differences is that majority of the pins are 3.3 volt compared to 5 volts. The ESP32 does output 5 volts because it has one pin that you can used to input a voltage, and then when you connect it via USB, you can use that same put to output 5 volts. For everything else is 3.3 volt tolerant. I will get into these communications protocols in the future sometime, but for serial peripheral interfacing, it has four pins, and for I squared C, it has two I squared C sets of pins. I squared C is, to not get into depth of it, it's just a communication protocol that lets you communicate with more than one device using the same number of pins. So with just two devices, you can communicate with, I think, a maximum of 124 devices just off those two pins, and it has two of them, so that's a lot more devices. And the big part of ESP32 is that it has onboard Wi-Fi and Bluetooth just built in. So there is a little bit of setup uh, required. This is where the Arduino IDE really comes in, because to do any setup, you literally just open up the IDE, go to Preferences, enter in that URL. That URL is a JSON object, which I'll get into, but it just tells the IDE, hey, I need to get this library, this library, and this library for it to work. And the next time you open up your boards manager right here, the Arduino IDE goes through, grabs those, adds them to your board manager, and then the only thing you need to do is click install, and boom, you're good. Then you can go to Tools, Board, and click the ESP32, and you should be able to program it. Tip: when you're programming it, hold down the boot button. This second button here is boot. It will not program unless you hold that button down. I spent like a good half an hour trying to program it, and I thought I had like a busted board, but no, this is just a little extra protection they have where you have to hold that button down, and then it'll allow it to be programmed. Oh, and this is just a reboot button. So the big allure of the ESP32 is the ability to work with Wi-Fi and Bluetooth. I'm only going to be covering Wi-Fi in this one. That's sort of the obvious applications for it. Bluetooth, I haven't had too much occasion to use it. But working with Wi-Fi starts like this. So essentially, you want to import after you've installed all the ESP-related board stuff. You want to include Wi-Fi.h, which does get installed with ESP32. Then you want to begin a serial. This is just begins a serial channel that lets you send messages back and forth, so you can view them in your serial monitor. Then you set it up. Just do Wi-Fi.mode, and this is turning into a Wi-Fi station, so it can receive Wi-Fi. You can also turn it into an outputting station and use this as a Wi-Fi server, as like a server on your a basic server on your network. A little more advanced, but it is possible. And you just disconnect if you're connected, delay. We're gonna print out setup is done, and then this is where we're actually using Wi-Fi. So after the setup's done, within this loop, it's just gonna say starting scan. Then it'll go through here, scan all the networks, prints out when it's able to scan them, and it'll just go through, print out the signal strength, the name of the Wi-Fi, and if it's encrypted or not. This is useful when you're initially setting up the device, just to see what Wi-Fi networks you're able to access and what you can log into after when you want to actually use them. And the output of this basic program would be this right here. So I ran this at my house, and I got all these different networks. I didn't want to share all of them just because they're pretty descriptive. Um, but yeah, it was able to detect like 11 of them, which I'm pretty surprised at. I live in the suburbs, so the houses are a little spread out, and the tiny little antenna on this thing was able to pick up Wi-Fi houses, like multiple houses down the road, which is just crazy to think about. But yeah, this here shows the different strengths. They work on the decibel system. So here's a little chart explaining how to read that. Unsurprisingly, this is my home Wi-Fi, and it's able to get that fairly strongly. So now that we're able to see those networks, we actually want to be able to connect with them. I only included pictures here because all the code starts with my Wi-Fi ID. I didn't want to copy and paste that in there. But once you do have your Wi-Fi found, you would just replace that with a name, replace this with the password. You just go through, begin Wi-Fi mode again, but this time you add the SSID and password, print it out. This is just telling you, hey, it was able to connect. Then you have to init the Wi-Fi, just actually set it up, connect to it. And it's just going to print out the signal strength. So when you reboot the ESP32, this is just a bunch of random stuff it outputs telling it rebooted, but this is really the output of the program where it connected to Wi-Fi and it took it a couple seconds to. This is the internal IP it generated, and then this is the signal strength it was receiving at the time. So in less than like 30 lines, we're able to not only view what the Wi-Fi quickly, but we're also able to connect to it very, very fast. So now that we have that out of the way, let's actually make something. I've worked with this board before, and just as it made connecting to Wi-Fi extremely easy, it also makes using the Wi-Fi very easy as well. Uh, so what we want to do for this like quick load project is we want to use Wi-Fi, utilize an API, which I'll get into, and then parse the JSON API response, and then display only the data we want. APIs are um, small detour into APIs to JSON, but APIs are just programming interfaces, application programming interfaces that let you either connect to some server to query some request, or even between computer programs. It just lets your code talk to other code and get the information it needs. It's used for database interactions. It's used to build a bunch of stuff on the web. Just everything's got an API. And one of the specific things you can do with the API is submit a GET request. GET request is a request or a query to go to the server, go to some program, and grab specific information that we want. And it's just going to grab that and give us the data. The data it gives us back is in JSON format, which is JavaScript object notation. The name kind of just stuck. It's based off of like some old JavaScript text formatting standard, but everyone just calls it JSON, even though it isn't really linked to JavaScript anymore. It's just standard way of exporting data. But it works on key value pairs, where you're gonna have this JSON object right here. Then that object is going to be filled with a bunch of these keys and with values. So first name, last name, location online, all these are keys, and these are the values they correspond to. So if I wanted to access a person's first name, only thing I'd have to do is do the object, use array bracket syntax, and enter in the key, and it should return Sammy. This can contain both booleans, true, false, and integers, or just strings as well. So you do want to have some idea of the data you're going to be getting back. Otherwise, because we're using C++, it's not gonna it's gonna have some data like conversion issues. Uh, so this is an amazing way to exchange data, use it as well. But as I said, we are using C++, and native C++ is just going to see this as text. And writing your own little text parser program, you can do it once, but you're never going to be able to get it exactly as you'd like. That's why someone invented Arduino JSON. It's a library that you can again install through the Arduino IDE that just lets you put in this JSON response, and it'll format it, parse it, do everything you need, and just let you access the data exactly like this. That's the cool part about Arduino JSON. Like you would install it by just going to Sketch, include library, manage libraries, and search for Arduino JSON and install. Just one install, and it downloads it, puts it where it needs to be, and you can call it like any other H file. There is, however, a caveat where looking at this response, if the only thing we want is first name, last name, and followers, we're gonna have location and online. That is still data that's there. That's data that's taking up space. So when you're working with microcontrollers, some of the issues you run in with is space. They're small, low power devices, so they're not going to have massive hard drives on them that let you save everything you want. So you do want to be concerned with how much data you're using and using that space like efficiently. So so what Arduino JSON did to help kind of mitigate that is they included these things called filters. They're not complicated like signal filters you would see in 306 or something, but they're just little booleans that you could set saying, I want this data, I want this data, but this data is false. What that'll do is as this data is coming in, it'll save this, and just delete this automatically for you. Not even save it into the ending structure. It'll just get rid of it. So that opens up quite a bit of extra working memory. The documentation for Arduino JSON is also like some of the best documentation I've ever seen. Not only does it describe like every single function, what it does, a lot of example programs, but it also has this little applet built into the website that lets you enter in your own JSON response and will tell you how much data it's going to potentially need, and like helps you create filters to whittle that data down. And honestly, that's just the best thing ever. For a random library, having that sort of support is just awesome, being able to work with it. I'm not really going to be covering filters. They're on the documentation that I'll have included at the end, but that would make this a bit too long. So essentially, this is, at the end of the day, just a library, and this is going to work like any other library you've imported in 202 or in 341 or anywhere. It's just more objects. Initially, you're going to have this static JSON document, which is going to be kind of like a container that holds the draw JSON data, and that's allocated on the stack. The stack is in charge of like memory you've defined, while the heap is memory you're allocating during the when the program is running. There is a heap version of this program that uses pointers and stuff, but that has some extra caveats, and I wanted to keep this a bit simple. But it's just going to allocate all this on the stack, and the size right here, I believe it's based on bytes, so it can get pretty. The ESP32 has 4 MB, so unless you're parsing a very large JSON file, you won't run into memory issues. But depending on the project, and it can be a concern. So after you've got defined a container to hold your JSON right here, you're going to deserialize it, and that's taking this raw data and making it into something like this, where you can actually work with it. That this is, and it returns an error object. That error object is just going to tell you, hey, I was able to do it. No, I wasn't. And you can, or no, I wasn't. And you could base the rest of your code off and have multiple like an if statement built off of if it was able to get the data or if it wasn't. The best part about the library is that it still lets you use JSON syntax. So here, right here, where you're using a key to get that value, this wouldn't really be too easy to use in C++, and it does use like templates and does a bunch of other stuff to make it usable. So you are still doing type, variable name, object, and then key, and it gives you that data. And yeah, it's very well done. Highly love this library. So back to the project. So in terms of what we want to do with the Wi-Fi, we want to get a joke. This is right here is the joke API. Returns a JSON object. JSON is what we want. It doesn't have any key, and it allows for 120 calls per minute. And since it has no key, it doesn't have a limit, like a monthly limit or yearly limit on how many calls you can make. It's just a simple API that's going to let you grab a joke. Then we have Open Weather, which is a weather API, but it needs you to register. And one thing to keep in mind when you're registering for Open Weather is that the key they give you is not going to initially work. You're going to have to wait like 30-ish or so minutes for that thing to activate. I was using this API during like a hackathon I did, and I was ripping my hair out thinking this key is just not working right. And I made like 2 different accounts, and I just had to have it actually activate. This is a pretty big API. It takes a lot of server space for it to run, so there is a free option, but there's like multiple paid options as well, depending on what you're doing. So if you're doing some weather research and you need a lot of data to be able to query and get, you're probably going to want to use the paid one. But the free option gives you just about what you need. It lets you do 60 calls per minute, which is like a call a second, and lets you make 1 million requests per month, which is still pretty insane. You're going to be limited to certain parts. Like this gives you historical data, current data, and future data. It can also give you random like data of different places in the world that you wouldn't usually expect weather data from. And the paid versions allow you to do that. So here's an example response from submitting this request, like a basic jokes request. And yeah, this is what it looks like. First things first is error. This is always going to be there. If it had trouble getting you a joke, this will be true, but it was able to grab a joke, so it's false. Category, type, setup, and delivery. And I set all these to false just to make it school appropriate. Then an ID lang. So as I said before, this is a lot of data for that it's getting. We don't need like 90% of this data. The only thing we don't need really an error unless we want to like have it. The API has worked every time, so it's not really going to include make error or something important. We don't really need a category. We don't really need any of these flags, this ID, or even a language. Really, the only thing we need is just type, setup, and delivery. Um, so the Arduino JSON library, if you were using a filter, would automatically disregard all of this other pieces of text and memory that it's taking up and only give you these three pieces that we need. But yeah, this is just an example response where this is a string, any old string that you can that you would normally use. You can use that in an if statement to tell you the type and just print it out. I'll explain more on the next couple of slides. The weather API response. So that was the jokes one. This is the weather API response. I did this for UMBC. I just entered in some coordinates around campus. And again, just look at the amount of information it's giving you back, and we don't need like 90% of it. So we don't really need the coordinates. We know where we're going from. We could use this, but we don't really need it. We don't need clouds or anything. Really, the only thing we want is just temperature. The feels like temperature, min temperature, max, and maybe humidity. That's the only things we want, and everything else can be thrown away. Again, a perfect uh, application for filters. So we have these two JSON responses, but we have an issue. How do we actually get them? That's where this part of the code comes in, where not only do you want the Wi-Fi library, you also want the HTTP client library. Get requests work off of HTTP, and you need that library in there. I believe this also gets installed with all the board files you have with ESP32. Then I just included a string and the Arduino JSON. Initially, this is my Wi-Fi information right here. This right here is the container. So we're creating two documents that let us store the weather information we want, as well as the joke information we want. We're going to start up a serial begin. That's what we'll be able to view the data. And then Wi-Fi mode, as I've covered previously, setting it up as a Wi-Fi device that's able to receive Wi-Fi, not really outputted. Then this is just connecting to the Wi-Fi. So this is all in the setup. We only want to run this once. Once it's connected to the Wi-Fi, then we want to move on to what it's going to be doing continually with. So first things first is I made each of these APIs their own function. So initially, and make it like a self-contained function just to make it easier within the rest of the code. So initially, it's creating an HTTP object. It's making sure that the Wi-Fi is connected, since this is going to be running within that loop function for like until infinity, until we stop. We want to make sure before we start each request that it's able to access the Wi-Fi. Then we have an HTTP.begin, which is going to get our little or massive API string with the key, and it's able to. We say that here. Then we run a GET request. Just do .get. It's got the URL. This is the what tells it that we want to send it a GET request and not a retrieve request or a put request or any other type of request. This is error like testing to make sure that the API response was successful. If it's greater than 0, then we can actually parse it. Otherwise, we're just going to print out error. This is the part of the code that's actually parsing through and grabbing the response. So initially, the payload is just a raw return from this GET request, and that's a string. We can grab it as a string. We're going to take that, toss it directly into that weather container we made, and the payload we have, and it's going to return either an error object, which is going to tell us if it was successfully able to parse it or not. After we have it parsed, we interact with it just like any other JSON object. So we would have a type, weather. So if we go back here, we have this entire object, and inside that object, we have a smaller JSON object called main. That's why we do weather main, access that object, and then access the temp subfield. Same with feels like and humidity. And we're saving those as floats because, as you can see here, they are floats. Then we just want to print them out. So print out temp, fields, and humidity. Then this is if it was an error and you just want http.end. That way it clears up the get request, the URL has saved, and just lets the function end. This is all stack on the stack. So when this function goes out of, when these variables go out of bounds, it'll automatically clear up, but it's still good to have these free the resources type lines down here. This is the second function. We're going to be grabbing code for the jokes from the jokes API. 90% of the code is the same. Again, making an HTTP client, checking to make sure the Wi-Fi is there, but this time we have a different URL, a query URL. It's the jokes one. And then I blacklisted the obvious stuff. And same with get, grabbing that as a string, but this time we're putting it into the joke container. And the type of stuff we want is slightly different. So there was this right here, type. There's multiple types of jokes it has. It has one-liners and jokes that are like have a setup and delivery. So if it's two-part, it's gonna have a setup and delivery. If it's a just a one-liner, it's only gonna have one of these lines, which is for the joke itself. Um, and so right here, we're able to have it figure out which type it is. So I'm initially getting the type, saying if it's a two-parter, then we're going to have two separate variables it creates, setup and delivery, that grab both those informations and prints them out. If it's just a one-parter, I kind of got lazy with the variable names there, but it only just grabs the joke. There's nothing else. That and then for our loop, this is going to be running forever. It just prints out a little line, weather output, another line, joke output. Now it's going to be running, I don't have a delay on here, so it's going to be running about as fast as it can run. Probably once every couple seconds, just because it takes time to download and all that. But yeah, this is what the output looks like. So connected to Wi-Fi, connecting to Wi-Fi, connect to Wi-Fi. This is in the setup function. After it's connected to Wi-Fi, prints out that initial line, gets the weather output, outputs it, gets the joke, outputs it again, and keeps on going in this circle until you pull the power. But yeah, it's pretty simple way of doing this because at the end of the day, after you've got it within the string, you can do whatever you want. You can connect this up to a display and have it live display data to act as like a little screen you have on the side of your room, or you can make a local server and have this parse output from your own local server to control a device nearby or do whatever you want. Um, and this is just one small simple project that lets you know how to use that Wi-Fi and the APIs. But ESP32 is much larger than this. And there's so much other awesome stuff you can make. Any questions? All right. Not seeing any questions. That's about it. These are just all the different resources I used. This will be available online, so if you want to go through and look at some of the stuff more detail, highly recommend all these. But yeah, that's about it.